Hi everyone, and welcome to the Physical Science Unit 3 review. For this recording, please make sure you take notes. This is going to cover things you'll need to know for the unit test, and you'll want to have those notes ready for taking your test as well as submitting for extra credit. So as we get into the beginning of the review, if you're not seeing these messages before, make sure that you're going into content and getting into the lessons. Otherwise, you're just going in through here and you're missing some important information. So just a reminder to make sure you have the teacher graded assignment submitted. Make sure you've got the note guide complete and that you have all your keywords defined so that you do well on the Part 2 portion of the test. And you are able to use notes on your unit test, but no other outside sources. And remember that anything about a portfolio mentioned, those are not required in the middle school course. So as we get into the Unit 3 review, we'll take a look at some of the concepts. You definitely want to have a definition of covalent and ionic bonding. Maybe some examples of those would be helpful too. Chemical formulas, reactions, and equations. We'll talk through rates of chemical reactions. Remember those mixtures and solutions and know the difference in the heterogeneous and homogeneous mixtures. And also all of the separation techniques that were covered. And then we also want to make sure you understand the difference in the pH of an acid and a base. And once we get through this, you should be set to take your test. There is a student guide. Nothing in it is required to be submitted for grading. So as we get into the review, the first thing we're going to talk about is chemical bonding. And if you remember, that's just joining two or more atoms together. And sometimes one atom will lose one or more electrons and other atoms gain one or more electrons in a bond. And we know that that happens to form more stable arrangements of electrons. And after an atom has gained or lost electrons, it becomes an ion. So that's something that you'll want to note as well. And then what type of bonds form between a positively charged ion and a negatively charged ion. If we click on the answers below, it tells us that is an ionic bond. So you'll want to have that in your notes. An ionic bond is a positive and a negative. And then a compound, what is the compound that contains this type of bond called? And that is an ionic compound. So you could add that into your notes as well. And sometimes atoms form a stable arrangement by sharing one or more of their electrons. What kind of bond forms when atoms share electrons? And we know when they share, that is called a covalent bond. So have that in your notes. And what is a group of two or more atoms joined by bonds of this kind called? And that answer is a molecule. Okay, so lots of things to have in your notes there. There are some pictures here as well. You might want to add these into your notes. It's always helpful. If you see an image on the test and it says which kind of bond is this, then you would have it. So covalent bond here, you can see the sharing of the electrons. And an ionic bond shows here that this atom is giving away the electron here to form that ionic bond. All right, so important to know those. Next, talking about chemical reactions. When you mix certain substances, a reaction can occur and form a new substance. What are the substances that are mixed to react with each other called? So again, you need this definition. Substances mixed together to react. Those are called reactants. Remember, those are on the left side of the equation. And what are substances produced by the chemical reaction called? We know produced is the key word here. Those are called products. So have that as well. And then energy is always involved in chemical reactions. What's the name for a chemical reaction that releases energy? So we know that energy is going out, exiting, exothermic reaction. That's how you can remember that. Energy is being released. And what is the name of a chemical reaction that absorbs energy? So if it's absorbing it, it's taking it in. You can remember in, it's taking it in, endothermic reaction. And there are many different types of chemical reactions. What is the name of a chemical reaction in which a reactant breaks down into different products? So you have one thing breaking down into two or more different things, and that is called decomposition. So you can think about something decomposing. So it's one thing and it breaks down to form two different elements. So carbon dioxide can decompose and form carbon and oxygen. So you can remember that. And finally, what is the name for the process in which a solid product forms during a reaction involving a liquid reactant? And so imagine you have a test tube and you are mixing two different liquid solutions together, and a solid product forms, and it's asking what is that called, and that is a precipitation reaction, and in that little piece of solid is called the precipitate. So you can remember that. Write that down in your notes as well. All right, so chemical formulas. This is pulling information off the periodic table. So you're using the elements and their symbols to combine and form different molecules. And what is the name for a group of elements, element symbols that represent a compound? So this is a definition you'll want. That's called a chemical formula. So a group of element symbols that represent a compound, chemical formula. So identify the elements that combine to form each of the following materials. So here you're looking at sodium, Na. You're looking at chlorine, Cl. So remember, a lot of students look at this and think it's a C and an I, and you probably wouldn't see those letters like that together. So Cl, chlorine. And then this one we have hydrogen, 2 hydrogens and an oxygen. And for this sugar or glucose molecule, we have carbon, 6 of those, hydrogen, 12 of the hydrogens, and 6 oxygens. So it's just breaking down what you are seeing. So it's asking you what are the elements you're looking at. You're just naming the elements you see. All right, so again, using chemical formulas and understanding that those subscripts are these little tiny numbers, and that tells us it's to the right of the element. It tells us how many atoms there are in that compound. Coefficients are the larger numbers, so this one out in front of the element, and that indicates how many molecules of that compound are present. So we'll kind of go through that. And it's here asking, identify how many atoms of the given element are present in each of the following. So if we have how many sulfur atoms are in H2SO4. And so if we look at the S for sulfur, we don't see a little number next to it, a subscript, and we don't see a coefficient in front. So we know that there's only one sulfur. If we look at carbon, how many carbon atoms are there? So there's no subscript, but there is a 3 in front of it. So there are 3 carbon atoms. And then how many oxygen atoms are in this molecule, this compound? So you're looking at 4. There are 4 of this H2O2 molecule. So if we were to multiply that across, 4 times 2 is 8. And so there are 8 oxygen atoms. So that is how you get those. If we look at chemical equations, this is one of the harder things that students struggle with. So you will definitely want to write down the example that we're going to go through in your notes, so you have something to compare back to when you have to work through one of these on your own. So we use the chemical equations to show how the substance that react during the chemical reaction, what happens, how they end up on the other side. So in order for a chemical equation to show a reaction accurately, it must obey the law of conservation of mass. So remember, it has to be equal on both sides. And what does the law of conservation of mass state? You need to have that in your notes. Matter is not created or destroyed, so they are always going to be equal. And how is that obeyed in terms of the number of each atom on each side of the equation? So if we look, matter cannot be created or destroyed, so that the mass of the reactants must equal the mass of the products. And each kind of atom occurs as many times on one side of the equation as it does on the other, so the total masses have to be the same. If it's unbalanced, like this one is showing on 21, it is unbalanced. The question's asking, are they balanced or not? And identify the element that is not balanced. So here you have 2 hydrogens and 2 oxygens, and then you're looking, the arrow is the dividing mark. So now we're comparing, this is the products. We see 2 hydrogens, so that's equal, but we only see 1 oxygen. So those are not equal. So here this would not be balanced and the oxygens are not equal. If we look at this side, and sometimes you have to actually write it out so that you can compare. And in this case you have C6H12O6, so sugar molecule, plus 9O2. So let's figure out what we've got going on this right side. If you wanted to write this out with me, you would have C6H12O6 and then plus 9O2. That means we have 18 oxygens right there and 6 oxygens in this glucose formula. So when you add those together, we know that on the right side, the left side alone, we have a total of 24 oxygens. So we know that when we look over on this side, we've got to have that many. So over here we have 6 carbons. The carbon dioxide, we have 6 of those, 6 CO2. And that means we have 6 carbon. So if you had to even go further in writing that out, you could write 6 C's to represent that. And then you could write, if you have the O2, you have 6 O2s. So if you needed to draw that out so you could see it and understand it, there would be 12. So you could draw 6 pairs of oxygen to help you see that. So we've got the 6 CO2 plus this 6H2O. So if we're doing some math again, for the number of hydrogens over here, we've got 12. So we have 6 H2s. So it's kind of like doing the same thing we did before with the oxygens. We could draw out 6 pairs if we needed to visually represent that of hydrogen. So we have 12 of those, and then we have the 6 also carries over to this oxygen, so we have 6 as well. All right, so if you add up 12 plus 6, so if we're adding up all the oxygens on the right side, 12, is that right? And 6, so we know that that is 18 oxygens on this side, and we had 24 on the other side, so it is not balanced. So if we take a look at the answers there, we can kind of compare 22. It's not balanced. There are more oxygen atoms on the left than the right. And then you can see if we go through the last one and we count all of these, it is balanced. So hydrogen here, hydrogen, there are 2 here, but we see another one right there, so that counts. And then chlorine, and there's the arrow, so we have another chlorine, those are balanced. We have sodium Na, we have that here, and we have it there, so that's balanced. And we have an oxygen and an oxygen, that's balanced. And then there's our other hydrogen. So 2 hydrogens and 2 hydrogens. So that one's balanced. And that is probably the hardest concept to get out of the whole unit, the balancing equations. So write it out if you need to go through this and draw this part out too. It gives you a couple methods, then do that as well. So the next thing, not very difficult, is understanding just how fast a chemical reaction occurs, and you're just looking at the graph. So this is pretty easy. There are 3 factors that control how fast the reaction occurs, and you'll want those in your notes. Those 3 things are temperature, the concentration of reactants and products, so the concentration of those, and surface area. Okay, and we did that experiment with the bubbles so you can remember how those things were affected. And then the next one says the rate of the chemical reaction. Here you have an example of H2 plus I2 yields or produces 2HI, and it's shown on the graph over here. What do the graphs indicate about the amount of H2 and I2 as time passes? So look, it's pretty easy to see. Time is passing. Got something going on right here. We can see that it's obviously rising, right? So over time, we have more HI. Let's see, what do the graphs indicate about the amount? We did that. Based on the graphs, what happens to the amount of HI as time passes? So for 26 and 25, if we look, it's wanting us to know that the bottom graph tells you that the amounts of H2 and I2 decrease rapidly at first. So you see kind of a big drop, and then it looks like over here it's going to level out. And then the top graph shows that HI forms very rapidly, so it shoots up pretty quickly, and then over time it starts to level out. All right, and then finally, the last thing is, what is the term for the state of reaction when the forward and reverse reaction rates are equal? So even if you don't know what the forward and reverse reaction rate means, if it says something is equal, then you know your answer choice says equilibrium, that means something is equal. And so what that's meaning is the rate of reaction on the product side and the reactant side when those are equal. And that definition is something you want in your notes as well. All right, getting close to the end, heterogeneous mixtures and solutions. So a mixture can be either heterogeneous or homogeneous. Remember that a heterogeneous mixture, it looks different. So it's one in which the ratio of the different components of the mixture is different throughout the mixture. So this would be like Chex Mix or something where we can see the different pieces. It doesn't look like milk where it's looks like one continuous substance. Okay, so a homogeneous mixture is which the ratio of the different components is the same everywhere. So it's even, and those properties are the same all over. So milk is an example, apple juice, something like that. If you think about orange juice, it could be heterogeneous. If you had a lot of pulp in it, it would look a little bit different. The ratios might be different. So examples of heterogeneous mixtures include mud. This says milk and oil and vinegar salad dressing. It's interesting that they're calling milk heterogeneous. You don't really see the different parts. Examples of homogeneous mixtures are a sweater, antifreeze, and vinegar. So I think that milk is incorrect here because oil and vinegar, you can see the different parts. But when you're looking at milk, you cannot see the different parts. It all looks like one substance. Unless the milk is like raw milk right from the cow and the cream comes to the top. Then that would look like a heterogeneous mixture. But otherwise, the milk all looks like one thing. So I think we have an error there. And then you also need to remember the distillation. Remember we talked about that. Water boils off while the salt remains behind. And then the water that condenses, again, does not contain any of the salt. So when you're talking about what happens during the process of distilling salt water, remember distilling things is one way of separating things. So just remember that point there, that the water boils off the salt and the water that condenses, again, that salt is gone. All right, and let's get to page 8. The last thing we're going to cover is the pH scale. So you may want to draw this out in your notes. Things that are very acidic, battery acid, it's a pH of 1, stomach acid, vinegar. You've got acid rain. And then we're getting a little more neutral. Milk, saliva, pure water is very neutral. It's a pH of 7. So that's something you want to remember. If it has a pH of 1, it is very acidic. If it has a pH of 14, it is very basic. So going up the scale here, it is increasing in alkalinity, and that would be baking soda, hand soap, things that feel slippery when you put them on your hands, like conditioner in your hair. Household ammonia, bleaches. If you've ever cleaned with bleach and gotten a little on your hand, you'll notice it feels very slippery. Lye, not something we use a lot, and it's really not healthy to touch that, but very alkaline substances. So just remember there that an acid increases the number of a certain type of ion when it's dissolved in water. So an acid increases the number of a certain type of ion. What type of ion increases in concentration when an acid is dissolved in water? So if we look at that, you've got the H plus for increasing in the acidity, and then the OH minus is decreasing. It's something that's more basic. So it's what kind of ion increases in concentration when a base is dissolved in water. You have that hydroxide, oxygen, hydrogen, that OH negative. And then you can measure the strength of acids and bases using the pH scale. What is the strongest acid shown on the scale? That was battery acid. And what is the strongest base? Yep, we did that. Strongest acid on the scale, strongest base is lye. So that covers the pH scale. And that brings us to the end of the review. So a couple of things to do is check out the big ideas. I encourage you to go through each of these slides, just making sure that you know all the material on each slide. These are excellent places that test questions. You will see something that looks very similar to this. So go through all of these, put anything in your notes that you may not have, and just make sure you're prepared there. If you're able to go through this and just, you can talk yourself through these little squares here and feel pretty confident, then you're good to go there. Vocabulary, you definitely, this is showing you a way to like graphic organize bigger words. You do not have to do that to prepare. You can practice with some of the words that you saw, so that would be good practice as well. Here are some questions that you can review. So there are 6 questions that would be really helpful, and anything you miss, you could just write down the question and the correct answer. So that's a great practice too. And then there's a couple of these that are good practice as well, definitely. You have 10 things to go through. Just remember that we aren't ever writing the short answer essay, so when it tells you to go through the short answer part, we don't do that. We have the vocabulary instead. So any questions before you test, please let me know. Otherwise, you will do great.